Case study 5.1 looks at the technology and the future of biofuels. And this is one of the most interesting evolving stories in the intersection of global energy and climate, for example. And biofuels began to become an important consideration when it was realized that biofuels could replace petroleum and thereby control the balance between imports and exports of petroleum. And what occurred was originally biofuels were driven by corn-based ethanol. And as we'll see, corn-based ethanol turned out not to be a particularly good solution. But as time evolved over the past 5 years, it's become very clear that biofuels are essential to the future of a stable climate. And the reason for that comes back to this point we made before, that aircraft require liquid fuels. And aircraft also consume a huge amount of energy, as we can see by our personal energy budget. But the total consumption of aircraft worldwide is only about 7% of the total petroleum output. And it turns out that biofuels are easily capable of supplying all the fuel required for aircraft. That means that aircraft can fly without contributing any net carbon dioxide to the atmosphere. But the other interesting factor is that the chemistry that is involved in the production of biofuels turns out to be far more interesting than was originally suspected. In fact, large research efforts across universities of the world are dedicated to analyzing the chemistry of this production of biofuels. So let's take a look at the structure of biofuels. The first point is that there are two clearly defined generations related to biofuels. The first generation biofuels were the fuels, primarily ethanol, produced from corn. And as we'll see, and see repeatedly, it turns out that it takes virtually the same amount of petroleum to produce a given amount of energy content in first generation biofuels as those biofuels produce themselves. So they represent no savings in terms of producing energy without contributing CO2 to the atmosphere. The second aspect is that the new generation of biofuels are distinctly different from that. The second generation biofuels are cellulosic in their origin. That is, they are created by a molecule that's discussed in some detail in this case study. But second generation biofuels require very little fossil fuels because they require very little fertilization. They grow and maintain the nitrogen content of the soil that they're growing in. And so their net production of fuel is accomplished without contributing carbon dioxide to the atmosphere. But the second thing that second generation biofuels do is that they don't compete with the production of food. The problem with corn-based ethanol was that it took a huge fraction of the available corn, converted that to ethanol, and that cut into the ability to produce food to sustain the global population. So second generation biofuels have these two important characteristics. They don't require any significant amount of petroleum to produce, and they don't compete with the world production of food to sustain people. So let's just take a quick look at types of second generation crops that can produce biofuels without introducing carbon dioxide into the atmosphere. We have switchgrass, eucalyptus, shrub willow, poplar, sorghum, sugarcane, and so on. And these crops can be grown in areas that are unacceptable for agricultural production. And this represents a huge amount of areas throughout not just the United States, but China, Africa, Europe, and so on. And so the second generation energy crops have a huge advantage in that they use space very efficiently, and they don't cut into the amount of agricultural space used to raise food for human sustainability.